Once again back to my YouTube channel Sriram Devarajan. Today I am going to discuss another set of problem from KSET 2024 Mathematical Science question paper. This is part 2 of KSET 2024. I already upload KSET part 1. You check my YouTube channel and go to my playlist, then you may watch part 1 of KSET 2024. Today I am going to discuss another set of problem from KSET Mathematical Science question paper. The first problem: pick out those function of f which maps from R4 to R3 for which the derivative given by the function jf will be two x1 x2 x1 square 0 0 x2 x3 x1 x3 x1 x2 0 last row 2x1 2x2 x4 square 2x3 x4 x2 square. Options are: first option f of x1 x2 x3 x4 which is equivalent to x2 square x1 square x1 x2 x3 x1 square plus x3 x4 square. Second option f of x1 x2 x3 x4 which is equivalent to x1 square x2 x1 x2 x3 x1 square plus x2 square plus x3 x4 square. Third option f of x1 x2 x3 x4 which is equivalent to x1 cube x2 x1 x2 x3 2 x3 square x4. Fourth option, f of x2 x3 x4 x1 comma x1 x2 square comma 2 x1 x2 x3 comma x3 x4 square. See, function f maps from R4 to R3 for which derivative of the function jf will be. This jf is nothing but Jacobian matrix. Since it's from since f maps from R power 4 to R power 3 means the matrix is 3 cross 4. First row, second row, third row, first column, second column, third column, this is fourth column. From this matrix, for which of the following matrix, for which of the following option we may get this 3 cross 4 matrix for the function defined by f for the first option, for the second option, for the f for the third option, and for the fourth option. Again I am repeating what I am going to say. We have to since the JF is nothing but Jacobian matrix, f maps from R power 4 to R power 3 means the matrix is 3 cross 4. It is given in the problem itself. We have to get this matrix from the four options. Whether first option, if you get the Jacobi matrix like this, you may check it out. Again from the second option, again from the third, again from the fourth. Out of the 4 option, which option we may get this Jacobian matrix. That's all. Solution: JF is nothing but Jacobian matrix since it is 3 cross 4. First row should be dou f1 by dou x1, dou f1 by dou x2, dou f1 by dou x3, dou f1 by dou x4. Second row, dou f2 by dou x1, dou f2 by dou x2, dou f2 by dou x3, dou f2 by dou x4. Third row, dou f3 by dou x1, dou f3 by dou x2, dou f3 by dou x3, dou f3 by dou x4. Last row, dou since it is 3 cross 4, 3 row 4 column. Don't write row F4. This is the this is Jacobian matrix with 3 rows and 4 column. First row, differentiation of f1 partially with respect to x1, x2, x3, x4. Second row, f2 with x1, f2 differentiation partially with respect to x2, f2 differentiate partially with respect to x3, f2 differentiate partially with respect to x4. Similarly for f3. Now I am going to check the option. What is first option? What is given? F of x1, x2, x3, x4, which is equal to x2 square x1 square, x1, x2, x3 last one x1 square plus x3 x4 square. This is f1, this is f2, this is f3. The matrix from this one, find dou f1 by dou x1. It is 2x1 x2 square. Dou f1 by dou x2, 2x2 x1 square. Dou f1 by dou x3, there is no x3, 0. Dou f1 by dou x4, again 0, there is no x4. Now differentiate partially f2 with respect to x1, x2, x3, x4. If you differentiate partially with respect to x1, x2, x3 with respect to x2, x1, x3 with respect to x3, x1, x2, last term 0. Now differentiate partially f3 with respect to x1. x1, there is no x2, 0. With respect to x3, x4 square. With respect to x4, 2x3 x4. Now I am going to check whether option 1 is the correct one. 2x1 x2 x1 square, but we are getting 2x2 x1 square. Option 1 wrong option. Option 2, f of x1, x2, x3, x4. What is given? x1 square x2, x1, x2, x3, last term. Option 2, x1 square plus x2 square, x1 square plus x2 square plus x3 x4 square. Again, this is f1, this is f2, this one is f3. Write in matrix with the first row differentiation of f1 with respect to x1 partially 2x1 x2, f1 with x2, f1 with x3, f1 with x4. Second row f2 with x1 partial differentiation, x1 x3, x1 x2, there is no x4, last term 0. Now differentiate partially f3 with respect to x1, with respect to x2, with respect to x3, with respect to x4, that is the last row. If you differentiate partially with respect to x1 for f3, 2x1 2x2 x4 square 2x4 x3. Now check whether option 2 is the correct one. First row 2x1 x2 x1 square 0 0, 2x1 x2 square x1 square 0 0, first row correct. Second row x2 x3 x1 x2 x1 x2 x3 x1 x3 x1 x2, x2 x3 x1 x3 x1 x2, first row correct, second row correct. Now I am going to check the last row, 2x1 2x2 x4 square 2x3 x4, 2x3 x4 x4 square 2x2 2x1. For this problem, option 2 correct option. Now I am going to discuss the second problem. Which of the following statements is false? First option, if f is monotonic on a comma b, then f is Riemann integrable if f is continuous on a comma b, then f is Riemann integrable. Third option, if the set of points of discontinuity of a function f on a comma b is finite, when f is Riemann integrable, fourth option, if the set of points of discontinuity of a function f on a comma b is infinite, then f is Riemann integrable. The problem is from a real analysis. We have to choose which one of the statement is a false statement. Solution: see, for the fourth option, if the set of points of discontinuity of function f on a comma b infinite, then f is Riemann integrable. For this problem, the solution by a well-known result, first option is true statement. If f is monotone on a comma b, then it is Riemann integrable on a comma b. Again, option 2 is also true statement. If f is continuous on closed a comma b, then it is Riemann integrable on closed a comma b. Option 3 is also true statement. If f be bounded on closed a comma b, set of point of discontinuity of f is finite, then f is Riemann integrable. For this problem, option 4 is the false one, that is the correct option for this problem. We have to pick out the false one. Why I am saying false? Only for finite points of set of discontinuity of a function f is Riemann integrable, not for infinite. Therefore, for this problem, option 4 is the false statement. Therefore, option 4 is the correct option. Now, problem 3rd. Let M3R be the set of all 3 cross 3 real matrices if A belongs to M3R as 1 comma minus 1 comma 1 by 3 as eigenvalue, then the eigenvalue of a power minus 5 are first option 1 comma minus 1 comma 243, second option 1 comma 1 comma 1 by 243, third one 1 comma minus 1 comma 3, fourth one 1 comma minus 1 comma minus 1 by 243. See, in this problem, one 3 cross 3 real matrix is given that may be taken as M3R. If this A matrix belongs to M3R, which is a 3 cross 3 real matrix, this A has 3 eigenvalue, 1, minus 1, 1 by 3. Then we have to find the eigenvalue for A power minus 5. Since eigenvalue for A 1, minus 1, 1 by 3. This is lambda 1, this is lambda 2, this is lambda 3. By a well-known result, if lambda is an eigenvalue of A, then lambda power n is an eigenvalue of A power n. Here in this problem n is minus 5. Therefore, lambda power minus 5 eigenvalue of A power minus 5. First lambda 1 eigenvalue of A is 1. Second eigenvalue is minus 1. Third eigenvalue is 1 by 3. Find lambda 1 power minus 5, that is 1 power minus 5. Second eigenvalue, find lambda 2 power minus 5, that is minus 1 power minus 5. Third eigenvalue, lambda 3 power minus 5, that is 1 by 3 power minus 5. What is 1 power minus 5? 1 by 1 power 5, 1 by 1, 1. What is minus 1 power minus 5? 1 by minus 1 power 5, 1 by minus 1, that is minus 1. What is 1 by 3 power minus 5? 1 by 3 power 5, which is equal to 1 by 3 power 5 is 243. This is nothing but 243. Therefore, 1 minus 1, 243 eigenvalue of A power minus 5. For this problem, first option is the correct one. Fourth problem. Dimension of vector space of all symmetric matrix A, which is equal to Aij of order n greater than or equal to 2 with real entries A110 and trace 0 is first option n square plus n minus 4 by 2. Second option, n square minus n plus 4 by 2. Third option, n square plus n minus 3 by 2. Fourth one, n square minus n plus 3 by 2. Here we have to find the dimension of the vector space of all symmetric matrix. We know very well dimension of vector space of all symmetric matrix is n into n plus 1 by 2. But here we have two conditions. One is A11 0, another one is trace 0. Solution. Here 2 Li condition, one is A10 and trace 0. Since we know very well dimension of vector space of all symmetric matrix is n into n plus 1 by 2. Since we are here we are having two conditions, therefore dimension is n into n plus 1 by 2 minus 2 Li condition. Therefore n square plus n by 2 minus 2, which is equal to n square plus n minus 4 by 2. First option is the correct option. Problem number 5. Let F be a differentiable function in a comma b which of the following statement is not correct. If f dash of x greater than or equal to 0 for all x belongs to a comma b, for all x belongs to open a comma b, then f is monotonically increasing. Second option, if f dash of x less than or equal to 0 for all x belongs to open a comma b, then f is monotonically increasing. Third option, if f dash of x less than or equal to 0 for all x belongs to open a comma b, then f is monotonically decreasing fourth option if f dash of x equal to 0 for all x belongs to a comma b, then f is a constant function. See, in this problem f is defined as differentiable function in open interval a comma b. We have to choose the false statement, that is not correct. See the last statement, f dash of x is 0 for all x belongs to a comma b, f is a constant function. This is true statement because if f equal to solution, if f equal to c, what is f dash? 0. Therefore last option true. In the first option, if the derivative of f is greater than or equal to 0, f is a increasing function, that is monotonically increasing. This is true because derivative of f is greater than or equal to 0. In the third option, derivative of f is less than or equal to 0, then the f is a decreasing function which is monotonically decreasing. This is also true statement. First one true, fourth one true, third one true, only the second one it is given as derivative is less than or equal to 0, f is monotonically increasing. This is false statement, that is not correct. For this problem, option 2 correct option. This is part 2 of K-set. This is part 2 of K-set 2024. I already upload part 1 in my YouTube channel. You just check the playlist and watch my part 1 video. I will upload more problems from K-set 2024 from the mathematical science question paper. This is part 2 of my K-set 2024. I will upload more problems from K-set 2024. Subscribe my channel, share my channel to a friend and like my channel. Thank you.